Our solar system is one of the most bizarre and fascinating places in the entire universe. From planets that spin backwards to moons that shouldn't exist, there's so much weirdness happening right here in our cosmic neighborhood that most people don't even know about. Let's dive into some of the strangest things hiding in plain sight around our sun. First, let's talk about Venus, which is genuinely one of the most alien worlds we know. Venus rotates backwards compared to most planets. Scientists call this retrograde rotation, and it's absolutely bizarre. The planet spins so slowly that a day on Venus is actually longer than a year on Venus. That means the planet completes an orbit around the sun faster than it completes a single rotation on its axis. Imagine a day lasting longer than a year. That's the reality on our neighboring planet. But here's where it gets even stranger. Venus has an extremely thick atmosphere made mostly of carbon dioxide, which creates a runaway greenhouse effect that makes it the hottest planet in our entire solar system. The surface temperature reaches nearly 900 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is also 92 times stronger than Earth's atmosphere, which means the pressure on Venus's surface is equivalent to being 3,000 feet underwater on Earth. Yet somehow, Venus is actually closer to the Sun than Mercury on average, but Mercury is still hotter in some places because of its different atmospheric composition. Moving outward, we encounter Mercury, which has its own set of strange characteristics. Mercury has a huge iron core that makes up about 85% of the planet's radius. That's an unusually high proportion compared to other rocky planets. Scientists still aren't entirely sure why Mercury has such a massive core, but one leading theory suggests that a giant collision early in the solar system's history stripped away most of Mercury's rocky mantle, leaving behind this enormous iron center. Mercury also has something called orbital resonance with the Sun. The planet orbits the Sun 3 times for every 2 rotations it completes on its axis. This creates a fascinating rhythm where certain locations on Mercury experience the Sun rising, setting, and rising again during a single Mercurian day. Some places on Mercury never see the Sun at all because of this peculiar orbital dance. Now let's jump to the asteroid belt, which sits between Mars and Jupiter. Most people imagine the asteroid belt as a dense field of rocks where spacecraft have to navigate carefully to avoid collisions. That's actually completely wrong. The asteroid belt is mostly empty space. The total mass of all asteroids combined is less than the mass of Earth's moon. You could fly through the asteroid belt without seeing a single asteroid. It's not the dangerous cosmic minefield that science fiction has taught us to believe. Jupiter itself is absolutely colossal and strange in ways most people never consider. Jupiter is so massive that it actually orbits the Sun slightly off-center because the planet's gravity warps the space around it so dramatically. The Sun doesn't sit at the exact center of Jupiter's orbital path. Jupiter also has auroras, just like Earth does, but Jupiter's auroras are driven by a different mechanism. They're powered partly by the solar wind and partly by particles from one of Jupiter's moons, Io. Speaking of Io, this moon is one of the most geologically active bodies in our entire solar system. Io has more than 400 active volcanoes. The moon's surface is constantly being reshaped by volcanic activity. Sulfur and sulfur dioxide are ejected from these volcanoes, and the entire moon takes on different colors as these materials interact with radiation from Jupiter. Io orbits so close to Jupiter that the moon experiences intense tidal heating. The constant stretching and squeezing from Jupiter's gravity generates enormous amounts of internal heat that powers all that volcanic activity. Jupiter also has something called the Great Red Spot, which is a storm system larger than Earth itself. This storm has been raging continuously for at least 300 years, possibly much longer. Scientists don't know exactly why this particular storm has persisted so much longer than other storms on Jupiter, but it's one of the most stable, long-lived weather systems anywhere in our solar system. Then there's Saturn, which we all know for its spectacular rings. But here's something most people don't realize. Those rings might be relatively young. Some evidence suggests Saturn's rings formed only a few 100 million years ago, which is very recent in cosmic terms. The rings might have originated from a destroyed moon or from captured comet material. Saturn itself is also uniquely low density. If you could find a bathtub large enough, Saturn would float in water. Saturn has a moon called Enceladus that's genuinely mind-blowing. Despite being only about 300 miles in diameter, Enceladus has a subsurface ocean of liquid water beneath its icy crust. Geysers of water and organic compounds erupt from the moon's south pole. This makes Enceladus one of the most promising places in our solar system to search for extraterrestrial life. The moon's subsurface ocean might contain more water than all of Earth's oceans combined, despite the moon's tiny size. Titan, another of Saturn's moons, is the only moon in our solar system with a substantial atmosphere. Titan's atmosphere is actually thicker than Earth's atmosphere, and it's composed primarily of nitrogen with methane clouds. Liquid methane and ethane rain falls on Titan's surface, creating seas and lakes of liquid hydrocarbons near the moon's poles. No other body in our solar system besides Earth has stable liquid on its surface. Titan is genuinely alien in ways that are hard to fully appreciate. Uranus is strange in a completely different way. The planet rotates on its side. While most planets have their rotational axes tilted slightly, Uranus has an extreme axial tilt of 98 degrees. That means the planet is essentially rotating sideways relative to its orbital path around the Sun. One pole points directly at the Sun for half of Uranus's orbit, creating extreme seasonal variations that are unlike anything on other planets. We still don't know exactly why Uranus has such an extreme tilt, but the leading theory suggests a massive collision during the early solar system knocked the planet sideways. Neptune, the outermost planet, has the fastest winds in our entire solar system. Wind speeds exceed 1,800 miles per hour on Neptune. That's significantly faster than any wind on Jupiter or any other planet. Scientists still don't fully understand how Neptune, which receives minimal energy from the Sun, can generate such powerful winds. The planet generates more heat internally than it receives from solar radiation, similar to Jupiter, but the exact mechanism remains mysterious. Then there's Pluto, which we reclassified as a dwarf planet in 2006. Pluto has an enormous moon relative to its own size. Charon, Pluto's largest moon, is so massive relative to Pluto that the two bodies orbit around a common center of gravity that sits between them. From Pluto's surface, Charon would hang in the sky without appearing to move, always fixed above the same location. The Pluto-Charon system is almost more like a double planet than a planet and moon. The Kuiper belt extends far beyond Pluto and contains thousands of icy bodies. Some of these objects, like Eris, are actually larger than Pluto. In fact, Eris is the reason Pluto lost its planetary status. When astronomers discovered that Eris was larger than Pluto, the International Astronomical Union had to establish a formal definition of what constitutes a planet. Pluto failed to meet the criteria because it hasn't cleared its orbital neighborhood of other debris, so it was reclassified. The Oort cloud is a theoretical spherical shell of icy objects surrounding our entire solar system at tremendous distances. Objects in the Oort cloud are so far from the Sun that they take millions of years to complete a single orbit. This is where long-period comets originate. Sometimes, gravitational interactions cause Oort cloud objects to fall toward the Sun, becoming the spectacular comets we observe from Earth. The Oort cloud might extend halfway to the nearest star, which is absolutely staggering to consider. Our solar system also has some extremely unusual orbital characteristics. Several planets don't orbit in perfect circles, but rather in elliptical paths. Mercury's orbit is particularly elliptical. The planet's distance from the Sun varies dramatically during its orbit. Additionally, some planets have slight orbital resonances with each other. Jupiter and Saturn have an orbital resonance where Jupiter orbits the Sun 5 times for every 2 Saturn orbits. These resonances influence the overall stability of our solar system. The solar system also contains numerous small bodies that defy easy categorization. Centaurs are icy bodies that orbit between Jupiter and Neptune. They're intermediate between asteroids and comets, and we don't fully understand their origins. Some might have been captured from the Kuiper belt, while others might be fragments from collisions. They represent a class of objects that challenges our existing taxonomies. Perhaps most strange of all is the fact that our solar system appears to have migrated significantly since its formation. Models suggest that Jupiter and Saturn didn't form where they currently orbit. Instead, these giant planets formed closer to the Sun and then migrated outward through gravitational interactions with the protoplanetary disk. This grand tack hypothesis suggests Jupiter migrated inward first, before being pushed back outward by Saturn. This migration would have dramatically reshuffled the early solar system, potentially ejecting countless planetesimals and small bodies into interstellar space. The solar system is truly a collection of cosmic oddities and wonders. Every planet has bizarre characteristics that challenge our understanding of planetary formation and evolution. From Venus's backwards rotation to Neptune's unexplained winds, from Io's volcanoes to Enceladus's subsurface ocean, our cosmic neighborhood is far stranger than most people realize. The more we study our solar system, the more we discover just how much weirdness exists right here in our cosmic backyard.